Hi class, today we are going to continue with our work on solving systems using elimination. To solve a system, you have to start with the system, which is two or more linear equations that involve the same variables. And we know that our solution will be an ordered pair that makes both equations true. It's also possible that we will have a system that has no solutions, or that will be an infinite number of solutions. So as we started working with elimination on day one, we had problems. We were given problems that looked very similar to this. And the goal of elimination, we found out very quickly, was all in the name. We needed for our coefficients to be opposites so that one of the two variables would be eliminated. And so we did everything that we needed to do in order to set that up. And in yesterday's problems, most of the equations were already set up so that the variable for either x or y, that their coefficients were either the same or opposites. So the most we had to do is to multiply by -1. All right, for example, these look like two of the problems that you had in your homework today during class. But here the y's cancel out because the coefficients are 1 and -1. In the second example, we have -6 and +6. And notice that when we add the two equations together, this is why sometimes this method is called linear combinations. We need to combine the two, we're adding two equations together, and then our variables are eliminated. I know in both of these equations we eliminated the y's, but you don't have to. Okay, so our first example today is the system 2x plus 5y equals -22, and 10x plus 3y equals 22. What I need to do is determine whether I need to eliminate either the x's or the y's, and I am going to first compare the coefficients of the x's. And as I'm looking at the coefficients of the x's, I have a 2 and a 10. And what I need is to be able to add these two equations together and have the opposite coefficients. So what could I multiply 2 by that would produce a 10? Because I realize that both 2 and 10 will divide into 10. Well, I could multiply the equation by -5, and that would produce a coefficient of -10x, which is the opposite of +10x. But I also know that whatever I do to the left side of the equation, I must do to the right side of the equation. So I need to multiply the right side of the equation by -5 as well. So the second equation doesn't need to be changed, only the first equation. When I multiply both sides by -5, my new equation is -10x minus 25y equals +110. And the second equation stays the same, 10x plus 3y equals +22. All right, so when I combine my two equations together by adding them, the x's are eliminated. Hopefully they are, because that's what we set it up to do. The y coordinates add to a sum of -22y, and 110 plus 22 is 132. Okay, so I need to divide this out. 132 divided by 22 is equal to 6. So my y value is -6. So I know that my y value is equal to -6. Let's go back and take a look at our steps. The first thing we did is we eliminated a variable, but first we had to change one of the equations so that we had opposite coefficients, and we chose x. We solved for the remaining variable because after we eliminated the x's, the remaining variable was y, and we solved for y. The third step is to solve for the eliminated variable. Well, x was the eliminated variable. We can either use the first or the second equation, okay, either this one or this one. It does not matter at all which one we choose. I'm just going to use the first one. So I know that 2x plus 5, and I know that y is equal to negative 6, must be equal to negative 22. I'm going to solve this equation. To solve it, I'm going to combine 5 times negative 30, so minus 30 equals negative 22. Then I'm going to add 30 to each side. And once I've done that, I have 2x equals 8. To solve this equation, I need to divide each side by 2. And that gives me x equals 4. Okay? And I need to write my answer as an ordered pair, 4, negative 6. It's a very good idea to take your calculator out and make sure that 4, negative 6 actually works. For example, go back to your first equation. 10 times 4 plus 3 times negative 6 should be 22. Okay. All right, as I look at that equation, 10 times 4 is 40. 40 plus 3 times negative 6 would be 40 minus 18, and yes, that is 22. It doesn't take very long to check your solution, but once you check your solution, all right, you can feel very confident that you did the work correctly. Let's take a look at a second example. Negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. The first thing I'm going to do is line the two equations up. Negative 2x plus 15y equals negative 32, and 7x minus 5y equals 17. We always want to be as efficient as possible. So as I take a look at the x values, the x terms and their coefficients, the smallest value that both negative 2 and 7 would divide into is 14, but that would require multiplying both the top and the bottom equation. So before I do that, I want to look at the y's. Okay, the two y terms have coefficients of positive 15 and negative 5. I recognize right away that negative 5 will divide into 15, or that 5 will divide into 15, and it's only a one-step process because I would only need to multiply the second equation, the bottom equation, or the red equation, by 3. So I'm going to go ahead and do that. And multiply the bottom equation by 3, knowing that I have to multiply both the left side and the right side by 3. Top equation stays the same. Negative 2x plus 15y equals negative 32. For the second equation, 21x minus 15y equals 17 times 3, 51. I am going to combine these two equations together. Okay, and when I do that, negative 2x plus 21x is 19x. The y's are eliminated, and negative 32 plus 51, oh, isn't that convenient, equals 19. When I divide each side by 19, x is equal to 1. So I've finished step 1 and 2. All right, so now I am ready to continue with step 3 by substituting the x value back in. All right, so to solve for y, I have negative 2 plus 15y equals negative 32. Adding 2 to each side, we gives me 15y equals negative, oops, made a mistake here. I was thinking ahead and wrote that down incorrectly. This should have been a negative 32 that I am adding to 2. So negative 32 plus 2 is negative 30. All right, so when we solve, we need to divide each side by 15, which gives us y equals negative 2. So our solution is the ordered pair 1, negative 2. Again, don't forget an ordered pair is always written in alphabetical order, x, y. And do one final example. 4x plus 2y equals 14. Okay, first step, just like the other two, is to write both equations. Okay, and one right above the other, and make sure that they are both in standard form so that the variables are lined up. Okay, I am going to compare the x's. Okay, as I look at x's, I'm thinking the smallest number that both 4 and 7 will divide into is 28. And the smallest number that both 2 and negative 3 would divide into is 6. Okay, 6 seems much easier to work with than 28, so I'm going to eliminate the y's. So what must I multiply the first equation by? Well, 2 and 3 both divide into 6. What do I need to multiply the top equation by so that 2, okay, or what do I need to multiply 2 by so that it is equal to 6? That would be a 3. So I have to multiply both sides of the first equation by 3. The second equation, okay, needs to be multiplied by a positive 2, because 2 times negative 3 will give me a coefficient of negative 6. Okay, I'm going to be really, really careful with signs. It's easy to make a sign error. All right, so with the first equation, I'm going to distribute the 3, giving us 12x plus 6y equals 42. And the second equation, 14x minus 6y equals negative 16. As I combine terms, we have 26x, the y's are eliminated, equals 42 minus 16. This is a big coincidence. It's also 26. I know that happened in the last problem, but that doesn't always happen. When I divide by 26, I find that x is equal to 1. Okay, so I have found the value of the first variable. It does not matter which equation I go back to, either one of the original equations. The first one has smaller numbers and all positive, so I'm going to work from that. So 4 times x, which is 4 times 1, plus 2 times y equals 14. All I need to do now is solve this. It gives me 4 plus 2y equals 14. To isolate the y, or to solve for y, I need to subtract 4. That gives us 2y equals 10, and then divide both sides by 2. That gives me y equals 5. So when I write my solution, I'll make sure to write it as an ordered pair 1, 5. 1, 5, I just want to do a quick check to make sure that this works. Let me go back to the second equation. 7 times 1 minus 3 times 5. Sure enough, 7 minus 15 equals negative 8. All right, I hope you have a great evening. Make sure you bring your notes in tomorrow, and during class time you will be working on more difficult elimination problems like what you saw in the video today.